Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to wrap up our discussion on spatial data by talking about how this non-spatial data gets connected to and represented in spatial data. And so we kind of already talked a little bit about this when we talked about raster data, but I just want to sort of overview how this works. So if we remember back to our discussion, we're going to separate this out into vector and raster. Right. So with vector data, what happens is we have our geometry. Right. So we have our geometry. So we have our coordinates. And we have what I said was the unique ID. Then we have the attribute table, right? And I said, by and large, we were going to talk about this later. Well, now's the time. So the way that vector data stores its information, right, is if we have some geometry. Let's just make a quick polygon here. Right. So we have our FID. Let's clean that up just a little bit. We have our FID, right? We already talked about this. The feature ID is the unique ID, and then we had our coordinates. So we have 1, and then we have some x's and some y's, right? What we also have is we have an attribute table, right, that has an FID of 1. But then it has data, right? It has attribute 1. Attribute 2. Right? Attribute 3. Right? So on and so forth. Right? And you could have 2 which has some x's and some y's. Right? You could have 3 that has some x's and some y's. Right? This part here, this is the spatial part that we talked about before. Right? This right here is called an attribute table. And this attribute table uses the same object ID right? So this one object ID here matches up with this one here, right? And the attributes, these are going to be the non-spatial data, right? So this could be the color. So you might have red, green, blue, right? This would be a nominal variable that we've measured for all of these, right? Attribute 2 could be something like the quality. So it could be okay. Try and not be quite so messy. It could be something like okay, good, best. Right? And maybe attribute 3 is the area of the polygon, right? So let's do like 347, 312, and 217, right? The main thing I want you to get out of this is that what we've done to store the non-spatial, to connect the non-spatial and the spatial data for vectors, is we have this unique ID that connects the coordinates used to map it with the attributes, which are all of the different non-spatial data. So each column is a different non-spatial data set. Each row is a feature, okay? Each column is a variable. Each row is a feature. and they're connected by the object ID to the geometry. Okay? Again, I just want to repeat that because hopefully it's clear. Vector data uses attribute table. The attribute table stores each object as a row and each piece of non-spatial data as a column. They're connected through this object ID. That's how vector data does this. We've already talked about how raster data does it, but I just want to reiterate here for comparison. Right? So with raster data, right, we have this arrangement of evenly sized grid cells. Right? And inside of each grid cell is a value. Right? This value, this is the non-spatial data. Right? The value inside of the cell, that's the attribute. Each cell is going to have its own measurement. Okay? So hopefully this is a review, right? We've already talked about cell values, that cell value is the attribute. The big difference here is that if we wanted to have a second attribute for vector data, all we have to do is add a column to the attribute table. If we wanted to add a second attribute for raster, we would have to duplicate this entire structure and give it a different cell value, right? So this is attribute 1, right, with its values, right? Because again, the cell values are the attributes, right? If we wanted another attribute, what we would have to do is we would have to literally copy the entire data structure with different attributes, right, with different cell values, right? So the yellow and the red are different cell values for the same area, right? So this is attribute 2. Right. Hopefully that makes sense, that the cell value, you can only have one cell value per grid cell. If we want to measure a second thing, we have to duplicate the entire raster data structure and put a new cell value in an entirely separate data structure. So we essentially have two different rasters here. One for attribute 1, one for attribute 2. For vector data, if we wanted to have more than one attribute about a given feature, all we have to do is add another attribute to the attribute table, keeping that feature ID the same, and it will just be pulled over and connected to the coordinates through this unique ID. Hopefully that made sense. If you have any questions, as always, please reach out. Thank you.